Hello, and welcome to episode 15 of Chemistry in 15 Minutes or Less. My name is Audra, and this review lesson is on chapters 6 and 7, part 8, Molecular Polarity and Intermolecular Forces. That is a large topic for something that is going to be very, very, very small. Intermolecular forces are different from intramolecular forces. Intramolecular forces are things like bonds, but we're focusing on the other side of that. Basically, polarity is caused by an unequal distribution of the electrons around an atom. This is what causes either a negative or a positive charge. Now, I'm going to go in decreasing energy. The ones that we're going to do first have the most energy, and I'll tell you how much they are, versus lower amounts of energy. And the one that has the most amount of energy is an ion-dipole interaction, which is where you have, for example, a cation here, and a dipole over here, and they are attracted to each other. Now, the energy state of this is between 40 and 600 kilojoules a mole, and this type of interaction would happen between, say, sodium ion and water. Now we know that the charge is unequal here because oxygen is much more negative than hydrogen, but that's just for an example. Now, something that's very important is going to come next, which is a hydrogen bond. Now, that looks confusing for something that we all probably understand because hydrogen bonding is what holds water together. So I'm just going to go ahead and draw a better example. For it to make more sense. The hydrogen here is still attracted to the oxygen, even though it's already bonded here. This has between 10 and 40 kilojoules a mole of energy, and it relies on something with a high energy of oxygen or nitrogen or fluorine. It's not based on the hydrogen having high energy. Now next up is what's called a dipole-dipole interaction, which is a dipole and a dipole interacting. You can see the two sides, polar opposite, pulling on each other. Now, this has between 5 and 25 kilojoules per mole of energy, and would happen between something like iodine bonded to chlorine, attracted to another molecule of the same thing. Now, an ion-induced dipole is different than the ion-dipole interaction we saw at the top. Basically, we have an induced dipole because this molecule is nonpolar. But it has a dipole induced because of the attraction to the cation over here. This has between 3 and 15 kilojoules a mole of energy, and would happen between something like, say, iron 2 and O2, oxygen. Now we have a dipole-induced dipole, which you'll notice sounds sort of familiar, which will be similar to the ion-induced dipole, except it's a pre-existing dipole pulling on a nonpolar molecule. That's what this means, is that it's nonpolar. This has between 10 to 10 kilojoules per mole of energy, and it would happen between, say, hydrogen and chlorine and another hydrogen and chlorine. Now the last one is something very, very, very important. It's called London dispersion forces. Now this is basically two induced dipoles attracted to each other. This has generally very small amounts of energy from 0.05 to 40 kilojoules per mole, and happens between just about anything. This is what's important. All matter has London dispersion forces. This is what creates states of matter. Basically, solids have higher London dispersion forces than a liquid. A liquid has higher London dispersion forces than a gas. That's what keeps it together or tightly packed versus not. It doesn't have to have an ion or a dipole in order to stick together. This is a basis of life and a basis of chemistry. This is also, in essence, what would cause surface tension in a liquid, for a slightly less aggressive example. I know this one was a little short again, but this is not something that I remember spending a lot of time on in class, or I guess I didn't pay that much attention to in class. Also plausible. But with that, this should conclude episode 15 of Chemistry in 15 minutes or less. Feel free to leave questions or suggestions in the comments below, and be sure to follow the in-video links, check out the playlist, or head over to my channel for more videos on chemistry review. As always, I hope this helps, and have a great day.